Maintenance has evolved through 4 generations, each an improvement, yet none fully sufficient. From reactive repairs to AI-driven pattern matching, the industry has improved its response to failure but hasn't solved why machines fail. Each generation addressed a real gap, yet none eliminated failure at its root cause. From reactive fixes to AI pattern matching, each step brought us closer to understanding machine failures. Reactive maintenance was the norm for much of the 20th century, especially in plants that couldn't afford better solutions. It's the most expensive strategy per unit of uptime, accepting failure as inevitable. Replacing parts on a fixed schedule, regardless of condition, seemed logical. Yet, it often led to unnecessary replacements and introduced new failures, as seen in the Waddington effect. A single threshold on vibration amplitude signals when something is wrong, but not what or why. It generates alarms without deeper understanding, leading to context and trajectory blindness. Pattern matching AI finds correlations in large datasets, but lacks understanding. It can't explain why patterns exist, and without physical understanding, it can't distinguish dangerous faults from benign conditions. Each generation solved a specific problem, like repair capability or planning discipline, but none addressed the underlying issue: understanding why machines failed to prevent future failures. The economics of each generation differ significantly. From costly reactive failures to planned CBM and AI solutions, the leverage increases as we move from reaction to elimination. Rapid AI rejects the premise that failure is inevitable. By combining physical understanding with AI, it aims to prevent recurrence through diagnostics, reasoning, and permanent elimination. All 4 generations fall short of eliminating failures. Most failures are random, and while AI finds correlations, it lacks causation. Rapid AI aims to bridge this gap by preventing failures permanently.